Scientific revolution. Revolution. A complete change in power. That's what we're talking about today. Ullius in verba. These are the words of the Royal Society of London. They translate to, on the words of no one. It kind of means question authority or see for yourself. It wasn't always like this. In fact, to really understand how things changed, we have to go all the way back to the beginning, all the way back to ancient Greece, back to about 400 BC. Look at that. A bunch of small little island nations. Greece wasn't unified. The only thing that kept them unified was that they spoke Greek. Everybody was different. It wasn't like the Egyptians or the Babylonians with some king telling everyone how to think. Not in Greece. They all argued and they all disagreed and they all debated. And one of the greatest thinkers of their time was a man named Aristotle. There he is, right there, walking with his teacher. No, he's not the old one. Aristotle's the guy in the blue shirt. Now, Aristotle was one of those guys who looked out at the world and he wanted to figure out what made up the world through observation, through logic and reason. He is the very first scientist. And he looked at the world around him and he determined that the world was made up of elements: earth, air, fire, and water. He would describe it as so: a piece of wood, if we light it on fire, it would burn more, thus releasing some of its fire element. As the smoke came out, it would then release its air element. As it continued to burn, the sap would leak out, and there you have your water element. And then finally, when that piece of wood was all cooked up, be nothing left but charred earth. This is what he believed. He believed that everything was in a state of change because of these elements. But when he looked up into the heavens, he didn't see any changes. Everything is always the same. So he came up with a fifth element, an element that he called ether. And this ether kept everything up in the stars, up in the heavens, from changing. In fact, he believed because they were circular stars and circular planets, and geometry, the circle or sphere was perfect, it was divine. And he came up with a concept of the earth being in the center of this sphere, surrounded by rings, like rings of an onion, and each layer holding a planet, having it circle around the earth. And in the final layer of the onion, that's where the stars are. And the stars weren't really even stars, but they were spikes of crystal piercing that onion skin. This, of course, is going to be the universe that will be adopted by the Catholic Church for the next 2,000 years. We call this a geocentric universe. And many people just went along with it. They said, hey, it works. The stars are moving, the planets are moving, because from our perspective, it looks like everything is moving around us. But there were some problems. Like, for example, Mars looked like it was doing loop-de-loops. So many medieval scientists or scholars would rather come up with reasons why Mars would do loop-de-loops than question Aristotle. But as Europe changed dramatically due to the Renaissance and the Protestant Reformation, and as the growth of universities gave structure to burgeoning questions about the world, educated Europeans began to examine the world around them with new vigor. The results were revolutionary. In 1543, on his deathbed, Copernicus published The Revolution of Heavenly Bodies. Just as the Counter-Reformation was gaining momentum, Nicholas Copernicus developed a mathematical theory that asserted that the Earth and other celestial bodies revolved around the sun, and that the Earth also rotated on its axis daily. This was pretty shocking stuff to many of the establishment. The Earth's position at the center of the universe was widely accepted. Copernicus's heliocentric theory of the solar system brought about much debate and much skepticism, but it wasn't until Galileo that Copernican model really took off. In 1632, Galileo published his dialogue concerning the two chief systems of the world. He wrote the work in Italian in order to reach a wide audience. Using observation, he observed the pendulum and how it swung and the principles behind it, and in fact developed the principles of the pendulum that we use today that help create the clocks that we use. Aristotle thought that when you dropped two things, they would continue to accelerate no matter what. And he also believed that the weight of an object determined how fast it would go. And there's a famous story with Galileo dropping two different size cannonballs from the top of the Leaning Tower of Pisa, showing that even though they were different sizes and different weights, they fell at a constant rate at the same time. Now, Galileo had heard about a Dutch astronomer who had developed a telescope, and so he built his own telescope, and he started pointing it to the heavens. And there he is looking at Jupiter. And as he's looking at Jupiter, he notices that Jupiter has spheres or moons circling around it. He says, wait, this explains Copernicus's idea of circles or planetary objects rotating around other things. So he starts doing the math. He then invites his friend Kepler to take a look. And Kepler looks at it and starts publishing a book explaining that the planets are actually moving around the sun just as Copernicus had said, but not in perfect circles, but in ellipses. And he even comes up with some rules to explain how these ellipses work. The closer the planet was to the sun, it would move even faster. Kepler and Galileo, both using mathematics and observation, started to change the way we look at the universe. Copernicus and Galileo, of course, were two fathers of scientific method. But it took more than a century for the method to be widely used. There were other contributors. One such person is a man named Francis Bacon. He published the works on inductive logic. He asserted that scientists should amass all the data possible through experimentation and observation, and that the proper conclusions would come from these data. 20 years later, a French philosopher by the name of René Descartes starts questioning everything he knows. And now he's applying his great mind to the idea of existence itself. Everything that he believes in. How can he believe in it? Up until now, everything he's believed in he's been told what to believe. So he questions it. What does he truly understand? He takes all the things he's been told in the world and he kind of shoves it off the table. And he reasons to himself that the only true thing that he understands is that he's thinking about it. He comes up with the phrase, cogito ergo sum. I think, therefore I am. At this moment, he realizes that if he starts at the very beginning and then looks for data and observation, you could come up with the answers instead of just listening to someone telling you this is the way it is. Observation and data will provide you the answers. Science isn't coming up with the reason why things happen and then prove it to happen that way. No, science is to look at what's happening, think about it, take data, test it. And that's what Bacon and that's what Descartes were saying. Bacon was saying it in a logical, scientific way. Descartes was saying it in a philosophical way. Finally, we come to probably the greatest scientist of the time, Sir Isaac Newton. In 1682, he published his Principia Mathematica. It contained the three laws of motion and Newton's universal gravity. In it, he explained how gravity affects apples, pencils, birds, buildings, you, I, planets, stars, the universe. Everything works on the same system. And it's his laws of motion that we use today to help us leave the confines of our own planet to explore our own solar system. He had to create an entirely new form of math we call calculus, just to prove the movement of the planets and how the sun moves around in the universe. So what did all this questioning of authority do for us? It created a revolution. Up until now, we followed the authority. We believed in a world with rules we could not explain, that could only be run by some greater deity. We've created laws that define and unify our comprehension of all the existence and transformations within our universe. These laws are grounded in scientific method and mathematics. The scientific revolution, coupled with the Reformation, will be the instruments of change during this time period. Sir Isaac Newton was a great man, but he realized that his greatness was built on the works of others. He once said, "If I have seen further, it is only by standing on the shoulders of giants." And yes, these were the giants that changed our understanding of the world we live in and the universe in which it sits.